Okay, so we're also going to be looking at hyperbolas with a center other than the origin. And that means that we're going to once again be dealing with a center of hk. And the h value is associated with that x value, and the y value is associated with the k value. So if you want to identify the center of a hyperbola, you need to take the opposite values of the h and k when identifying the center from the equation. So the hk just moves your hyperbola around the xy plane. And now, in order to find the focus, we need the center along with the c value. In order to find the vertex, we need the center along with the a value, and so forth. So let's go ahead and just get into this with a couple of problems here. We want to find the standard form equation for the hyperbola whose transverse axis has endpoints at -2, -1, and 8, -1, and whose conjugate axis has a length 8. Let's go ahead and plot these points and plot points that make up our conjugate axis and try and come up with the equation based off the graph. Okay, so I'm going to go ahead and just get started with the transverse axis endpoints, which represent the vertices of our parabola. This tells me that my transverse axis here is parallel to my x-axis. That means that I'm going to be dealing with x squared over a squared. Let's figure out what the center of this hyperbola is. We know that the distance from -2 to 8 is 10, so that means I need to go a distance of 5 to find my very center. This means that my hk value is 3, -1, and if I want to find endpoints of my conjugate axis, because it has a length, I simply need to go up 4 from the center and then down 4 from the center. Alright. This tells me a and b, which means that a squared is 25 and b squared is equal to 16. So I essentially have everything that I need for the equation of the hyperbola. And we have our x squared over our a squared. We have our y squared over our b squared. And that's all that this particular example is asking. However, you knew that I was going to say that, didn't you? I want to go ahead and figure out what the graph actually looks like. So I'm going to go ahead and show you all what the graph actually looks like right now. We have our A's and our B's located, and so that means that we can identify the rectangle that shows us the asymptotes that bind the parabolas. My transverse axis is parallel to my x-axis, and this -2, -1 represents a vertex of my parabola. 8, -1 represents another vertex, and voila, there's our hyperbola. What if, however, you knew that was coming, didn't you? What if I said, what is the equation of the asymptote? We know that the equations of the asymptotes represent a line. So I write out y equals mx plus b, and I got to figure out my m and my b value. Let's go ahead and deal with the positive slope first, once again. Alright, so the slope is found with the a and the b values. So from my center, I see that I would need to go up a distance of, how far is that? We go up 4, and then we go to the right a distance of 5. So that means my slope is a 4 over 5. And now I need to figure out my b value. And it's not good enough to guess. It looks like it's going to be a -3, but I might not have drawn perfectly to scale, and I might be guessing. So I want to be absolutely certain. And so I'm going to plug in another point that's on my line. And so I'm going to plug in the center, HK. I'm going to plug that in when y is -1, x is 3, and I need to solve for b from here. Okay, so I found the equation of that asymptote with the positive slope, and 17 over 5 is 3.4. So my guess would have been wrong if I guessed -3. We're actually going through at about 3.4, -3.4. Okay, let's finish up with this last problem here. We want to find the center, the vertices, and the foci of the hyperbola. Let's start off with the center. Our center, HK. So we take the opposite of the 2. We got a -2 and then a +5. And then we have a squared is over the x squared. So that means a squared is 9. And we have the b squared is equal to 49. This tells me that my transverse axis is going to be parallel to my x-axis. Let's go ahead and plot the center and the a and the b values. And let's go ahead and get a visual of the hyperbola and then come up with the vertices and foci. Okay, so from my center, I went out 3 and to the right and to the left, and that will identify the vertices of my hyperbola. We could just see what those coordinate points are. However, if you wanted to figure out what those points are formulaically, you would need the center, and you would need to add and subtract onto your x value of your center. The y value doesn't change for the vertices. So let's see here. I would need to add and subtract 3 onto the x value of my center. So that means that I have vertices at -5, +5, and also at 1, +5. Let's find the focus points. So we need to find the c values. So I plug in a squared and b squared, and I end up with c equals plus and minus the square root of 58. And remember that the focus points are within the cup of the parabola, and our parabolas are shooting out this way. I know that because these are my vertices here, and remember that the focus points are along the transverse axis, which is right here. I need to figure out where those focus points are. What is the location of those particular coordinate points right there? I need to add and subtract once again onto my x value. So let's go ahead and do that. I take the add and subtract onto the x value of my vertex. So I take the -2 and I add and subtract the square root of 58 to find those focus points. The y value stays the same. Okay guys, I am super tired. It is Friday and it's 3:30 and I want to go home, and I'm not really here even though I'm here. Hopefully this was good enough. And if you have questions, we can talk about it this week. Okay. Hope you're having fun on the college trip, and not to make you guys jealous or anything, but we had way more fun in class. We had the most fun day that you would ever imagine. It was awesome. So awesome. We had a party with Cool Ranch Dorito chips and soda pop, and it was really neat. Michael sang a Britney Spears song on the piano, and it was really cute because the whole class kind of started singing along, and then we all broke out into this a cappella of Britney Spears, and it was really fantastic. You guys on the college trip really missed out. All right, see you guys soon.